lines of influence during nodal transmission of moving loads. It's lesson number 2.13 from the book Mechanical Systems Calculations of the Marine Facilities. We consider an example of the mechanical system consisting of the main beam. Main beam is A, B, C, and this beam on two supports, A, the fixed hinge, and the B, sliding hinge. And the auxiliary beam 0, 1, 2, 3, 4, 5 consists of the panels. Panel in each span of the panel is sizes of the span D1, D2, D3, D4, etc. And the panels connected in the auxiliary beam and the nodes 1, 2, 3, 4. And we have as well the cross beam. Cross beams is in the same nodes 0, 1, 2, 3, 4, 5, etc. And the cross beams communicate the load of the moving load or the panels of the auxiliary beam to the main beam. The question is can we find the panel, the line of the influence of the force moving load of unit force of the unit weight, unit force of weight of F1 equal to 1 on the main beam, how it impacts, considering the mechanical system consisting of two parts as part of the main beam and auxiliary beam, besides the two parts as nodes as well, and the cross beams. So first of all, we must to work out the line of the influence, assuming of the moving load on the bending moment on the main beam in the point K, assuming that the load, just suppose that the load moves along the main beam with not the panels. And to do that, we have to have the ordinates in the definite points. For example, in the point K located from the left support A to the A distance, and from the right support B to on the B distance, and the magnitude of the bending moment here of unit load is product here in the point K, product of A by B divided by LL, distance between these two supports and the main beam. So on the hinges, on the supports hinge, on the support fixed hinge A and the hinge B, we have zero bending moment. So the impact, if the force F1 unit force assumingly moved along the main beam directly with not the auxiliary beam, the panels are just about directly on the main beam, it will appear the bending moment in the main beam with of the linear line of influence, and we can determine this by 3 points. 3 points because we have the vertex, the triangle shape of the line of the influence. 0 magnitude of the bending moment when the unit force located on the support A. 0 magnitude of the bending moment in the point K of the main beam when the assumed load located on the point B, and the product A by B divided by L if the moving load located in the point K. So besides, we have to consider the influence of the panels on the line of the influence of the moving load on the bending moments in the point K of the main beam. We can consider the span of the main beam between 1 and 2nd supports, 1 and 2nd cross beams, which communicate the force from behalf the unit load to the main beam. It's 1 and 2nd supports of the 2nd one panel. On the panel, we have the support as if we assume that this panel separately, so we have the action of the force in the place of X, and what is the reactions of the supports in the definite one panel is the support is the forces from behalf of the main beam to the panel, second panel. So, but the supports are the force support is d minus 6 divided by d2, d2 minus 6 divided by d2. And the right one support is x divided by d2. This is considering the rotation moment balance around the point 2 and the point 1. So R1 we have when considering the rotation of this panel around the point 2. And consider this the arms of the action of the force F1, because arm relative to the point 2 is G2 minus X and remain, and the force rotate counterclockwise. And the reaction in the point 1 rotate clockwise. Considering this balance, we find that the force reaction at the point 1 of the auxiliary beam of the panel depends linearly on location of the force of unit force along the panel in the span 1, 2. And direction in number 2, the same way we can find that equal to of unit force we equal to the x divided by 2 d2. So we can find that this direction in R2. And the dependent moment in definite point K, the point K corresponds the second span of 1, 2 panel. In the dependent moment, we can find as a total of product R1 by Y. Y1, Y1 is ordinata of the line of the action of the unit force. If we assume that on the main beam acts two forces, one force R1 and R2 on behalf of the auxiliary beam, on behalf of the panel, R1 and R2. And the influence of the force R1 on the bending moment of in the point K, we can find, assuming that R1 is is like a force, and yeah, the arm is we can have the from the line of influence factor of the bending moment from this place to K in the point of the application of the first force is Y1. So we product Y1 by R1, and we have the influence on the moment K from the force, if we assume force R1 located in the point 1. Exactly the point, the force R2 from the second support of the auxiliary beam of the panel when it loaded by the force 1 is acts on the moment 2. So two forces act simultaneously because this load is together simultaneously creates two forces R1 and R2. And we find that the moment on behalf of the force R2 is the product of R2 by the ordinate of line of action on the main beam if assume that unit force would be in the point 2. So we substitute these equations for R1 and R2 into the equation for the bending moment in the point K of the main beam, and we can find that the bending moment in point K is a linear dependence on the location of point of the application of force 1 along the span 1, 2 of the panel of the auxiliary beam. That's why we have two points if x assumed 0. So if the moving load is in the node 1 and the force applied in the node 1 on the secondary secondary beam, auxiliary beam in the port 1 applied the force if only here. So the moment of unit force we assume that this unit force acting on the main beam in the point K, if force acts here, the total force acts here. So in the moment here will be equal to y due to the second direction will be 0. R2 will be 0 if the load located only unit load in the point of the node 1. And if the load located in the point 2, the x equivalent to the d2, d2 is the span distance length of the span 2. And the line of the action magnitude is y2, the equivalent to the moment from unit force applied in the point 2. So finally, we have the approach how to determine the line of the action of the line of influence during nodal transmission for the one example of moving load. This line of action is the connection of nodes of the magnitudes of the line of the action of moving load on the bending moment in the main beam in the point K, assuming that we have no auxiliary and the auxiliary beam and the load moves right on the main beam, and we have originally one line of the influence, but we have to connect the adjacent ordinates by the straight spans, straight segment of line, and we have broken line finally. So we do not have this one vertex. We have only the connections of the points of the transmission of the load of the moving load, the points of transmission from the auxiliary beam to the main one. So we have the broken load as from the first point we have from 0 to the last and point of the auxiliary beam. This indicates the line of influence of the moving load or moved load on the auxiliary beam, its action on the main beam when the load transmitted to the main beam through the nodes. So first, we have to do the line of action of moving load on the main beam, assuming that perhaps we have no auxiliary beam and the load moves just by the main beam, and after that we consider the transmission and the points of the transmission of the load on behalf of the auxiliary beam to the main beam, considering each panel of the auxiliary beam separately and considering what the points of the transmission of how the points of transmission or from behalf of the auxiliary beam impacts the shape of the line of influence of moving load on the bending moment for the point K of the main beam. Questions and comments. Line of influence of bending moment during nodal load transfer. The considered elements of mechanical system: main beam, auxiliary, longitudinal beam, transverse beam, node panel. So if the mechanical system is not only one main beam and consists of the number of the beams, main beam and load moves along not the main beam but along the auxiliary beam, consists of the panels. So line of to find the line of influence, first we have to assume that perhaps that as the unit loads moves along the main beam. And after that, we consider the interaction of the main beam and the auxiliary beam in the nodes. And we next do the final line of the influence on the bending moment of the, assuming that the points of loading of the main beam is only the points of the connection with auxiliary beam. So that the loads communicate in the just only in the nodes from the auxiliary beam to the main one. This reduces the vertices of the line of the action of load on the main beam if we assume the main beam loaded itself not by through the auxiliary beam and through the panel of the auxiliary beam. Creation of the line of influence on bending moment without taking into account the nodal load transfer, which is when moving a load along the main beam. This is a stage of determining of line of influence of moving load on the beam consisting of two beams, the main beam and the auxiliary beam, and the communication of the load between the auxiliary beam and the main beam. So the first step is create line of influence on bending moment without taking into account the nodal load transfer. Just like the load acts itself on the main beam. The creation of line of influence on bending moment in section in when moving unit load within the panel. So considering the balance of the panel, we can find how the support reactions for definite one panel depends on the moving loads over the panel. And these support reactions at the same time is the communication points to the main beam. So these support reactions we consider next finding the line with the influence of moving load on the bending of the main beam. The final view of the line of influence of the bending moment in the section of the main beam without nodal load transfer, the transfer lines. So with nodal load transfer, with transfer. The final view is a broken line that is straight segments. The broken line consists of the straight segments which connected the adjacent magnitudes of line of influence corresponding the nodes of the connection of the main beam and the auxiliary beam. And these segments and these magnitudes we take from the assume that the load moves along the main beam with not the auxiliary beam, with not the panels and auxiliary beam, with not the connections between the auxiliary beam and the main beam. So, thank you.